All right, hi class. Today I'm going to take you through 12.6 Day 2 notes. So just a little reminder that 12.6 is on adding and subtracting rational expressions. So remember, in order to add or subtract fractions, you have to have a common denominator. So that kind of drives our problem. Once we get a common denominator, then we simplify the numerator and move forward. So we are on this example here, number 10. And a reminder, what do you do if the denominators are different? Sometimes you're going to have to factor first in order to determine the common denominator. So in the previous examples, we didn't have to do the factoring. We could kind of think about the two denominators and figure out the common denominator. So looking at number 10, you have 4x over x minus 3 plus 2x minus 7 over 2x minus 6. Notice these are not common denominators. So before we can actually add or subtract, we have to get these to be identical. So what we want to do is look at the denominators and check to see if they're in a factored form or not. So this x minus 3 is just a binomial, so it is a factor itself, so I'm going to group it just for visual. Now see this 2x minus 6? These two terms have a GCF of 2, so what I'm going to do is rewrite this as 2 times x minus 6, and then I'm actually going to cross that off because this is equivalent. And this is called factored form right there because it's in a product form. So basically we're supposed to now find the least common denominator. Oops, I see a mistake. I see that right there. So that should have been a 3. So what I did is I was double checking my work that if I distribute here, I should get this expression back. And I noticed that wasn't happening. So I'm glad I caught that because it would have been a little confusing if I didn't. So if we look at these two denominators, I want you to notice that they both have a factor of x minus 3. So they're close to being identical, but not quite. This left side, this left expression, is missing a factor of 2. So what I need to do is multiply the top and the bottom by a 2. So if I put a 2 here and a 2 here, now the denominators match. So the least common denominator is 2 times the quantity x minus 3. Which means over here, when we finally simplify our fraction, the denominator is 2 times this quantity x minus 3. So what I need to do now is go back here and simplify the numerator. So 2 times 4x is 8x plus 2x minus 7 is just going to stay like that. So it looks like this. We have 8x plus 2x minus 7. Now we need to look at this numerator and we need to clean it up. We need to simplify. So this 8x and 2x, those are like terms, so they combine to be 10x. And so now I'm looking at 10x minus 7 all over 2 times x minus 3. Now before I completely leave the problem and check out, I do want to look at the numerator and decide, could I factor that at all? So 10x and a minus 7, they have nothing in common, no GCF. It's not a degree 2, so you can't factor it into anything, but that's your final answer right there. You can leave the denominator as is. If you want to multiply that out, you certainly can, but that's your answer. Okay? All right, look at number 11. Here we have 5 over 3 times x plus x over x plus 1. Clearly these are not the same denominator. And so what we need to do is get that common denominator. But in order to get a common denominator, you have to have a product. And you can only multiply in order to get it into a common denominator. So if you look at 3x, that itself is a factor in this denominator, and then x plus 1 is a binomial factor in this denominator. So the left side here is actually missing x plus 1. And then the right fraction is actually missing the 3x factor. Okay? So I don't have a ton of space here, but what I want to do is multiply this side by an x plus 1, and so I'm going to kind of squeeze it in right here. And I need to multiply the bottom also by an x plus 1. And then this fraction here is missing the 3x factor. So I need to multiply by a 3x here and here. Okay, I'm not really multiplying right now, I'm just kind of getting it set up. So here's what it looks like, and I'm going to show this step. I don't always show this step. But we have this one fraction here, which is 5 times the quantity x plus 1 over 3x times the x plus 1 plus the 3x times the x. I just switched the order to put this 3 in front because that's more like what we see. And then over 3x times x plus 1. Okay, so notice that the denominators are now the same. And that means I can actually combine them. So what I'm going to do now is combine the numerators. So in this numerator, I'm going to distribute the 5. And so I am going to get 5x plus 5 plus, then I'm going to multiply these two together, which is 3x squared, all over 3x times the quantity x plus 1. So that's where we're at. And we look at the numerator, we're like, okay, can we combine anything? No, we can't. However, I am going to rewrite it because normally we put the degree 2 term first, then the degree 1 term, then the constant. So right now it looks like this, 3x squared plus 5x plus 5 all over 3x times x plus 1. And that is done. Just leave the denominator the way it is in a factored form and box that in because that is the answer. All right, let's move along to number 12. All right, here's number 12. We are looking at x over x plus 7 minus, now we need to be really careful about the minus there, x minus 1 over x plus 2. I'm actually going to rewrite this one up here because I want to show some work, and I'm going to leave some space between the first fraction and the minus symbol, and then also some more space in the second one. So we're looking at x over x plus 7, leaving some space, minus, leaving some space, x minus 1 over x plus 2. All right, so looking at the denominators, this denominator here is an x plus 7. That can't be factored. It is its own factor down there. And then this x plus 2, again, same idea. That is its own factor. So when you look at this fraction here, it is missing the x plus 2 factor. So I'm going to grab my green here, and I am going to multiply both the top and the bottom by x plus 2. Not literally right now. Right now I'm just writing it down. Okay, so now see how the x plus 2's are in both denominators? That x plus 7 needs to be in both denominators. So I'm going over here, and I'm going to multiply the top and the bottom by the missing factor, x plus 7. Now here's an important thing you need to realize is this numerator is a binomial. So I need to group it. Because what I'm going to have to do with the x minus 1 and the x plus 7 is I'm going to have to multiply those out by using the distributive property, which we call FOIL in this situation. All right, so moving along. What I need to do now is simplify the numerator, so I need to distribute the x into x plus 2, which gives us x squared plus 2x. And I'm going to actually group this right now. That is the numerator. Okay, this minus goes next, and then I need to multiply this out. Okay, so I'm going to go off to the side here, and I'm going to actually FOIL out x minus 1 times x plus 7. So first times first is x squared plus 7x minus 1x minus 7. These two go together as x squared plus 6x minus 7. And that is the numerator. So I'm going to write it here. X squared plus 6x minus 7. All over the x plus 2, x plus 7 denominator, because these are the same denominator. Therefore, I can make this fraction one fraction. So the next thing we need to do is actually simplify this numerator. So I need to subtract like terms. So x squared minus x squared is going to be 0. And then here we have a 2x minus this plus 6x. So 2x minus 6x is negative 4x. And then see this minus in front of this minus 7. So in essence, it's kind of like a 0 constant minus minus 7, which turns into plus 7. All over this quantity product, which you do not need to do anything with. I'm just going to leave it like that. And that is the answer. That is the difference between these two original rational expressions. Okay. So moving along, we're looking at number 13 here. This denominator is a trinomial. This denominator is also a trinomial. So we can't really tell what the missing factors are. We need to factor both of these to determine the missing pieces. Okay, so I'm going to go ahead and factor it below. Here we have two binomials. X and x is going to start both of them. We need two numbers that multiply to be negative 10 and add to be 3, which are negative 5 and positive 2. So I'm going to double check my work. Negative 5 and 2 multiplied together is negative 10. Added is, oh, see, that's a positive 3. So therefore this needs to be a plus 5. And then this needs to be a minus 2 in order for the sum of the two numbers to be a positive 3. I'm going to cross that off, and I'm going to factor this one very carefully, hopefully more careful than the last one. Alright, so we're looking for our two binomials that both start with an x. Two numbers that multiply to be negative 8 and add to be 2 are going to be a positive 4 and a minus 2. Okay? So what I want you to notice here is that they both have the x minus 2 factor, but the denominators don't match. And in order to add here, they have to match. So what's going to happen here is I don't need to look at the denominators and find what's missing. So this one here is missing this x plus 4 factor. That needs to be over here. And this right denominator needs the x plus 5 factor. Okay, so just kind of showing this in using some colors. So again, this side is missing the x plus 4 because it has the x minus 2, it has an x plus 5, but it does not have this one. So I'm going to go ahead and multiply both of these by the x plus 4 factor. And I'm going to underline it and underline it to show that they now both have an x plus 4 factor. They both have an x minus 2 factor. But this one on the right-hand side is missing the x plus 5 factor. So I'm going to use orange, and I'm going to multiply this by x plus 5 and this. Okay, and I'm going to underline these two because they match. So do you see the denominators are the same now? They both have an x plus 4, they both have an x minus 2, and they both have an x plus 5. That means my answer denominator is going to be this binomial product. I don't have to multiply it out, I'm just going to leave it. Okay? Now look at the numerator. Do you see how the original numerator here was a binomial? I want to make sure I put that in parentheses because I need to FOIL this out. And then I need to put this one in parentheses because I need to FOIL this out. Okay? So I'm not going to show every little step in FOIL. I did that above. This one here factors into x times, or multiplies into x times x, which is x squared, plus the outside product is a 4x. The inside product is an additional 4x, which gives you an 8x total. And then this last times last is a 16. All right, now the connection between the two is a plus. Now I need to distribute here. X times x is x squared. This outside product is 5x, and the inside product is minus 1x, which is a 5x minus 1x is a 4x. So this is going to be a plus 4x. And then last times last is a minus 5. Okay? That's the numerator right now. The denominator is the same denominator, so I can combine them into one fraction with the least common denominator. So now when I look at the numerator, I need to clean it up. I need to simplify, as we always do. So x squared plus x squared, those are like terms, is 2x squareds. And then I have an 8x plus a 4x, which is 12x. And then a 16 minus 5 is a plus 11. And then I just rewrite the denominator, which is x plus 4 times x plus 5 times x minus 2. And then we are done with this one. So that is the sum of the two original rational expressions. Okay? All right, we got two more. 14 here just has a little bit different factoring piece down here that we want to remember, and then it is a minus, so be sure you're super careful there. All right? So in order to subtract, we need a common denominator, and in order to determine a denominator, we need a factored form. All right? So remember, this is a difference of two squares. So we're going to square root x squared, and the two binomials are going to start with x's. And then we're going to square root the 16. So in our two binomials, they end both in a 4. And then for the inside product and outside product to cancel and be a 0, we need 1 plus and 1 minus, which will also give us the negative 16. So then that's done. Oops, up here I forgot to cross that out. All right, then we're going to factor this one. And we are looking for two numbers that multiply to be negative 24. Add to be 2. I'm thinking of a positive 6 and a negative 4. Let's double check. 6 times negative 4 is negative 24. 6 plus negative 4 is 2. Check. So I'm going to cross that off. All right, so notice then, right now, the denominators have an x minus 4 factor in common, but that's it. And they have to be exactly the same. So if you look at this denominator, it has an x plus 6. The one here does not. So we need to multiply both the top and the bottom by that x plus 6. And then right now I'm going to go ahead and group the x minus 3 because I know I have to. And then I'm going to underline these two because they now match. So this denominator has 3 factors. Let's say 1 green, 1 yellow. This one has only 2, 1 green and 1 yellow. This one here is missing over here. So I need to make sure that it is a part of this denominator by multiplying by x plus 4 top bottom. So I'm going to group this right away, and this is going to be an x plus 4 that I'm going to multiply by top and bottom. I'm going to underline for notes here. Those denominators are exactly the same. Okay? So now I'm going to start simplifying my 2 terms, but the denominator is going to be this. So I'm going to go ahead and put that down right now. You do not need to multiply it out. You just need to write it in a factored form. That is the least common denominator, so because they have a common denominator, we can now create one fraction. Now the connector here is a minus. And I'm going to extend this because I know I need it a little bit bigger. I'm going to multiply this out, that's going to go here. I'm going to multiply this out, that's going to go here. Then I'm going to combine like terms, but I'm combining them by subtracting the one on the left minus the one on the right. Okay? So now I'm going back here, I'm going to FOIL this out. X times x is x squared. The outside product is minus 3x, the inside product is plus 6x, which turns into a plus 3x. And then this positive 6 times negative 3 is a minus 18. That is that trinomial. Now we're going to do this one. So we have 2x times x, which is 2x squared. Then we have 2x times this positive 4x, which is 8x. That's the outside product. And then the inside product is plus 2 more x's. So 8x and 2x is 10x. And then last times last, 2 times 4 is a plus 8. So those are the numerators of each separate fraction. And now we need to subtract, okay? So be very careful. So you need to look at like terms. So see the x plus 2 and the 2x, see the x squared and the 2x squared. We're minusing, those are like terms. So it's a 1x squared minus 2 more x squareds, okay? And we get a negative x squared. So 1x squared minus 2x squared is negative x squared, right? Then we're doing a 3x, positive 3x minus 10x, which is a minus 7x. And then I'm going to do this minus 18 minus 8 more, minus 18 minus 8 more, which is a minus 26 over x plus 6 times x minus 4 times x plus 4. The order of these three binomials doesn't matter, okay? But that is your answer, okay? All right, let's do the last one. I mean, you could try this one, like pause this video, try it and see if you get the right answer, okay? So I'm going to work it out. I'm going to try to go a little bit quicker just to finish this video. But anyways, we're subtracting. We need common denominators. So we're going to factor here. We got x minus 5x minus 3. Product is positive 15. Sum is negative 8. Check. And we got this one, which is a minus 5 plus 4. Product is negative 20. Sum is negative 1. So these trinomials are done. Now I need to get a common denominator. So the left denominator is missing the x plus 4 right here. It's missing it. So I'm going to multiply here by x plus 4. I'm going to make sure I group that x plus 3 right now. And then I'm doing it on the bottom too. Alright, so now we have matching that. Ooh, I forgot to underline this one with yellow because that one was already matching at the beginning. And then my last one that I need in this right hand side is this x minus 3. So again, I'm going to group this, multiply this by x, whoopsie daisy, minus 3, minus 3. Okay, now we have matching denominators, which actually means that my denominator is done. So now I need to simplify up here. So again, in this numerator, we're going to have the product of these two binomials minus, right here, the product of these two, which is going to be a trinomial in there. Okay, so here we go. Multiply this out, we get x squared plus 7x plus 12. Multiply this out, we get x squared minus 9x plus 18. And now all we have to do is subtract like terms. Okay, so my denominator is going to be this binomial times this one times this one. On the top then we have x squared minus x squared. And that's actually going to cancel. Those are going to cancel away. It's going to be 0, x squared, which is 0. So we have a 7x minus minus 9x. 7x minus minus 9x is actually 7x plus 9x, which is 16x. And then I'm doing 12 minus 18, which is a minus 6. And the numerator is now cleaned up. The denominator is done. And that is the answer. Okay? So basically in 12-6, you're adding and subtracting rational expressions. And the key is you have to make sure that you have a common denominator. That drives the problem. So you make sure that you get your denominator in a factored form if it's not already. Then you find what's missing from the two denominators, multiply so that you get a common denominator, simplify the numerator, and then you should have your answer. All right? So, you know, basically, you got to work hard. The stuff is tricky. You need to practice. But just work hard, be nice, and things will fall into place for you. All right? Well, till next time. Ciao.